In this video, we are going to talk about the engine of a fighter jet. Engine is a highly specialized and powerful piece of machinery. It is designed to provide the needed amount of thrust for high-speed flight and agile maneuvering in the air. It also plays a critical role in the overall performance of the jet, including its speed, acceleration, altitude, and range. Engines are located inside the fuselage, behind the cockpit. Some fighter jets are single-engine like F-16 and F-35, while others are twin-engine like F-18 and F-22. Twin engines provide more power at the expense of more weight and fuel consumption. That's why F-16 is called lightweight fighter jet. The size of an engine can vary depending upon the model, but generally they are around 3 to 5 meters in length. Another thing to consider is the RPM, also known as revolutions per minute. It refers to how fast the fan of the engine is moving. Maximum RPM of an F-16 is 14,000 revolutions per minute. But how does the engine of a fighter jet actually work? It intakes air from the surrounding environment. You can see air intake of F-16 here. Air is then compressed at multiple stages. The compressed air is forwarded to the combustion chamber, where it is mixed with fuel and ignited. Finally, a high steam energy is produced that is directed by a nozzle in order to generate thrust and power any other systems. The F-16 has a single F-100 engine, which also has a high-performance afterburner. The afterburner injects fuel in the exhaust stream to increase the temperature up to 1700 degrees Celsius and give significant boost to the thrust when needed. It is due to this afterburner that the flames come out of the nozzle of fighter jet. Some fighter jets like F-22, Su-57, and Su-27 also come up with thrust vectoring, which means that engine's exhaust nozzle can be angled in different directions. This allows the pilot to control the direction of the engine's thrust to enhance the jet's turning and evasion capabilities. Speaking of F-22, it contains two F-119 engines, which are designed to provide high thrust and efficiency at both subsonic and supersonic speeds. F-119 engines are equipped with 2D thrust vectoring nozzles that are capable of deflecting exhaust gases up to 20 degrees in any direction. In addition to this maneuverability advantage, it also reduces the infrared signature of the aircraft, making it harder to get detected by other radars. This engine also features advanced materials and cooling technologies to withstand the high temperatures and stresses of supersonic flight. When such powerful engines are being incorporated in fighter jets, they usually consume so much fuel as well. On average, F-35 consumes 15 gallons per minute of fuel when flying without afterburner. When using afterburner, F-35 fuel consumption increases to 200 gallons per minute. Ending this up, engine is one of the most important structural components of a fighter jet, not only in order to fly, but during combat missions and dogfights.